Okay, continuing on with general math and algebra. Hopefully, this will help people just trying to get themselves prepared for tests. More knowledge, more math knowledge, the better. Uh, we have a timetable that we have committed to memory, and that's why I was asking you to commit those other things, the other bit, to memory. We've committed, these things to memory. And it's just something common. It's like a huge number we've committed to our mind. Like 9 times 9 is 81, or 8 times 8 is 64. I just wrote some of them up. But obviously there's other ones like 6 times 8, etc., our, our timetable. And we're going to come across this often, right? In general math, we need to know this. It's not something that is kind of optional. You can figure it out, but you still need to know this. Now, if you haven't been doing math in a long time, sometimes you forget things, forget your timetables. But, think about what it means. If you say, like, for example, 3, and I use dot, I don't use that X because that's used in algebra, or I use parentheses, 3 dot 4, that's equal to 12, let's say. But I don't remember what 3 times 5 is. I don't remember what 3 times 5 is, or maybe 3 times 6 or something like that. What is this? What is this saying? It's saying that I'm multiplying this value this many times. There's 4 3s that are being added up, right? There's 5 3s. 5 3s being added up. So the next value would have to be 3 more, because there's 5 3s. So that means I'm going to add 3 to get to the next value, right? Which would be 15. To get to the next value, I add 3 more to get to 3 times 6, right? And then that would equal 18, and etc., etc. That's the way our timetables are set up. And then we'll do the 4s and the 5s and the 6s, etc. Now, what makes algebra so powerful is all of this whole table, all of this drawing and everything can be summed up as A times B, which represents these values, is equal to the result C. That's it. That's our whole timetables and more. A times B equals C is all of this and everything we ever do. It's just it. A times B equals C. Something simple as this. And if you put it in a nutshell, A times B, in other words, these are next to each other, equals C. So if you don't know what A is, but you know what C and B is, you mentally put your finger over whichever one you don't know, and then going this way is division, and going this way horizontally is multiplication. For example, in this case, 3 and 5 would be here, 3 and 5. And what would come out here is 15. So the nutshell is this is called, would look like 15, 3, and 5. That's very powerful because you can solve a lot of problems, a lot of equations. Like if I said A times 4 equals 12. Solve for A. I don't know what A is. Well, you stick C here, which would be 12. You stick 4 here, right? And then out comes A. 12 divided by 4 is 3. So that's how you would get this value. It even shows you how to arrange the equation. So this is powerful. You should commit this to memory because this can be used in many, many, many situations. I'll keep bringing it up as it comes up. Also, your number line. I know it's corny, but this is very powerful too. And something you need to know about numbers that maybe you don't know. 0 and 1, except for 0 and 1, and going in this direction, we use the negative sign. That's what it means. The opposite direction. That's all it means. Instead of going this way, you turn around and go the other way. That's all negative means. You cannot do anything in math but add. That's all we do. And I'm not going to get into it much more than if you go 1, right, in this direction, that's adding, right? 1, 2, 3, 4, 5. If you go in this direction, that's also adding. 1, 2, 3, 4, 5, etc. But it's negative to tell you which direction to go in. Positive to tell you to go in this direction. That's all it is. But all we're doing in math is adding. Multiplication is just addition. That's all it is. Subtraction, division is a form of subtraction. And that's all it is, which is still adding. It's just this way. Anyway, we'll get into that some other time. If you're writing or making calculators, it's something that you would come across in programming, etc. You can only add. There's no such thing as subtracting. It's a procedure. Many things, even this, it's a procedure. 3 times 4 is equal to 12. We committed it to memory, but this is a procedure. And speaking of procedures, the reason why I wanted you to know your primes is because if you commit a certain number of primes into your mind, then you will know how to reduce numbers, fractions, I should say. For example, if you know something is 6 over 6 over 7, you know you cannot reduce this because 7 is prime, right? That's how you know you can't reduce this. Otherwise, you'd be sitting here, and this could be a larger number. It could, I could multiply this and say, something like whatever. It could be some other larger number. If you know it's not prime, then you know you can reduce it. Like 6. 6 can be reduced because 6 is a composite of prime numbers, 2 and 3. So 6 can be reduced, but 7 cannot be reproduced because 7 is a prime. That's why it's so important to know those primes. Primes make up composite numbers. This is a composite number. All the numbers above or between the primes, I should say, are composite numbers on the number line. You go 1, which is, other than 0, 1. You go 2, 3, which is prime. 4 is a composite number. 5 is prime. 6 is a composite number. 7 is prime. 8 is a composite number. What do I mean by composite? They're made out of primes. You check it out. All those numbers that's in between primes are all composite numbers. That's why if you see something that need to be reduced, like 8, 6, you know I can reduce this because neither one of these are prime numbers. They're composite numbers, so it can be reduced, right? I can reduce this to something that's common between them, which would be a prime number like 2, right? Because you break this into primes and you see, oh, okay, this has a common of 2. So 8 divided by 2 and 6 can be divided by 2, and then this can be reduced to, because I'm going off camera, so let me come back over this way. So this right here is the way to reduce it by its common, and you get 4 over 3. Now, I know I cannot reduce this anymore because 3 is prime. Even though 4 is made out of 2 primes, right? This cannot be reduced anymore. If you do something to the top to keep the balance, you must also do it to the bottom, which is what equation's about. Whatever you do over here, you must do over here, or else you destroy the balance between the two sides. That's what equality means. The same thing with this. This is a ratio, 4 to 3. 8 to 6 is the exact same ratio. If I put more up here or less here, or more here, I should say, whichever way, I destroy the imbalance. So 8/6 would never be equal to 4/3. So you have to keep them balanced. Whatever you do here, you must do here. See? So there's 2 problems I put out here. I think this video is long enough so far. And I'm gonna see if you can solve them And then I'm gonna come back and make another video that shows the solution. Oh, I do want to say one more thing about percentages. It's important. Think of percentages as dollars and cents. Like 14%. Think of that as 14 cents. 150% would be $1.50. Think of it like that. And then that's how you could convert from this to this decimal value, from this to this. All you're doing is moving this decimal point, which is after the 4, over twice. That's all you're doing. See? All you're doing is moving the decimal point over twice. But think of it as dollars and cents. And I hope that helps.